Okay, we're going to go through the first example. There's quite a few of them. We're going to go quickly. Very first question says to evaluate 4 to the power of negative 1. When we look at our rules for negative exponents, our rule says x to the power of negative 1 then becomes 1 over x to the power of 1. So in other words, this question, it just has to be turned into a fraction. We end up with 1 over 4 to the power of 1. What is 4 to the power of 1? 4 to the power of 1 equals 4. So our answer is 1 over 4. That's A. One B. Question says 8 to the power of 0. We look at our exponent rules of 0. Our exponent rule said x to the power of 0 is 1. In other words, anything to the power of 0 is 1. So 8 to the power of 0 is equal to 1. 1C. Negative 2 to the power of negative 3. Again, we look at our negative exponent rule, which is x to the negative 1 is equal to 1 over x to the power of 1. So we're going to turn this into a fraction. We're going to have 1 over negative 2 to the power of 3. We then have to equate negative 2 to the power of 3. So we take 2 to the power of 3 is negative 8. So our answer is 1 over negative 8. Okay, question 1D. They've given us a fraction, 2 over 3 to the power of negative 2. Now we need to look at our negative exponents, and we're going to expand a little on it. It says x to the power of negative 1 is equal to 1 over x to the power of 1. But technically, x to the power of negative 1 can be written as a fraction as over 1. So in other words, what we're doing is we're actually flipping this fraction and making the exponent positive. The 1 goes on top, the x goes on the bottom, and the exponent stays with the bottom number, and it becomes to the power of positive 1. So what we're going to do with this fraction is we're going to flip the fraction and keep it to a positive exponent. Okay? Now technically, you could have said that this was all outside of it. And now I've been drawing the 1 on the bottom of the fraction. But technically, it can be written like this, to the positive 1. The reason I've been writing it on the bottom, because what is 1 to the power of 1? It stays as 1. So we're flipping whole numbers. Our top is always going to stay as 1. And our x, well, depending on what it is. So in this case, we flip our fraction, we get 3 over 2 to the power of positive 2. So what that means now is we have 3 over 2 times 3 over 2. And according to fractions, we multiply the top numbers by each other and the bottom numbers by each other. We end up with 9 over 4. Question 1E has the number 0 to the power of negative 2. According to our negative exponents, which we already know, it's going to give us 1 over 0 to the power of 2, which is going to give us 1 over 0. 1 divided by 0, anyone know? Comes up as division by 0 because it's undefined. You cannot divide something by nothing. So it would be undefined. In your calculator, maybe it comes up as division by 0 or math error. Example 2 says carbon-14 is a radioactive element that decays to a half. So decays by a half, also represented as 2 to the power of negative 1 of its original amount after every 5,700 years. So it decays by half every 5,700 years. Determine the remaining mass of 10 grams of carbon-14 after 2 dates. So we're starting with 10 grams of the object. 10 grams of carbon-14. Okay. Question 1a says after 11,400 years. So first of all, we have to figure out how many decay cycles end up in 11,400 years. So I'm going to take my 11,400, and to figure out the number of cycles, I'm going to divide by a cycle's life, which is 5,700. 11,400 divided by 5,700 is 2. So what they're saying is there are 2 cycles. So because there are 2 cycles, we're going to take the original amount, 10 grams, and we're going to be multiplying. Let's make some room here. We're going to take the original amount, 10 grams, and technically we'll be multiplying by 2 cycles of a half. So we multiply by a half, and then by a half again. Another way to represent this, that's not what I wanted, would to take the number 10 and multiply it by 2 to the negative 1 to the power of 2 because there's 2 cycles. Okay? Now technically 2 to the negative 1 to the power of 2, there's a couple ways we could represent that. I want us to use our exponent rules. Okay? Now with our exponent rules, if you guys remember, power of an exponent, right now I have a power and another power of it. We have x to the power of a to the power of b is equal to x a times b. So in other words, what we're going to get here is 10 times 2 to the negative 1 times 2. So we're going to find a new exponent. That's going to give us 10 times 2 to the power of negative 2. Now what I'll need to do is I'll need to equate this. In other words, I need to make it a positive exponent. So I'm going to get 10 times 1 over 2 to the power of 2. That will give me 10 times, 10 times what? Technically, these are fractions. When I multiply the fractions, I do the top by the top and the bottom by the bottom. So I'm going to get 10 over 4, which is equal to 2.5 grams. Now just to show you, this would have been probably a logical way for you guys to have solved this. 10 times a half is essentially 10 times 0.5 times 0.5. Boom, 2.5. Yep. Oh, actually it would have been 10 divided by 4. Not divided by 2, divided by 2. Well, unless you got the answer, I guess. Yeah, it would work. You're right. Now, the reason I showed you the 2 ways of doing this is because I want you guys to be able to see the similarity. Obviously, this one was very simple to do. I want you guys to see the similarity between this because I'm going to solve the next question using exponents. Okay? Only the exponents. That was the same idea between those 2. Same type of question. This time they want to know, after 28,500 years, how much of the 10 grams is left. So again, we have to figure out how many cycles that is. So we're going to divide by the life of a cycle, which is 5,700. So 28,500 divided by 5,700, 5 cycles. Okay. Did I type the number wrong? Why did I get 5? 28500 divide 5700.
Oh, Adam just got destroyed.
So we decided to double check this. The book says 4.
That's wrong. What else is
So they're incorrect. This is 5 cycles. Okay? So with the 5 cycles, we're going to set up our question again. We have our 10 grams, which is going to be multiplied by our 2 to the power of negative 1 to the power of 5. Now, according to our rules, again, we remember that x power of a, to the power of b, we would multiply the 2 exponents. So we end up with x a times b. So in this case, we're going to get 10 times 2 to the power of negative 1 times 5. 10 times 2 to the negative 5. Now we know, again, according to our rules, x to the negative exponent can be written as a fraction flipped. So we get the number 10 times 1 over 2 to the power of 5. 2 to the power of 5 is 32. So we have 10 times 1 over 32. We multiply exponents. I get 10 over 32. And if I want an exact number, what did I just do? There you go. 0.312. 3125. Which is equal to 0.3125 grams. The reason the book got 0.6 is because they only put in 4 cycles. We put in 5 cycles.
wrong?
Because they calculated it wrong.